Welcome to our talk. This is how the SIG-Multicluster API specifications are used for real-world multi-cluster management. My name is August Simonelli. I work with the Open Cluster Management Project, and I work for Red Hat. And this is Ryan.
And I'm Ryan. I am a maintainer for the newly contributed CNCF project called KubeFleet, and I work for Microsoft Azure.
Cool. So let's talk a little bit about what we're going to speak about today. So we've done our intro, so that's one thing down. We want to kind of go over the SIG-Multicluster standards. I'm sure many in the room know them, but it's always good to recap them and to sort of baseline where we are with those things. Then we're going to demo some multi-cluster, because that's the fun stuff. We've got a mix of a recorded demo, that's me, and a live demo from Ryan, that's him sweating over there. And then we can do some Q&A. So the first thing I want to call out, and again, I know there are members of SIG-Multicluster here, but the idea behind this is that we want to define APIs and not implementations. We're not trying to say this is exactly how you do it. We want to define standards. We want to define ways that you can work within a multi-cluster space and be able to add your stuff to it easily. So to do that, there are 4 basic APIs that Ryan will cover. The About API, the Multicluster Services API, the Work API, and the ClusterProfile API. And you're going to see those demoed today as well. And why do we do this? Because by adopting standards, it makes it easier for the projects you work for and add to contribute and to be part of this. So whether it's something like CAPI or KubeFleet or whatever it is you're working with, we make it, by using the standard, we make it easier for you to fill those empty boxes. So you can come along and say, hey, my project wants to be part of multi-cluster, and this is the way that we can do that. And the idea, again, is that once we have these standards, the agreed upon community standards, it's not about bringing your standard in and dropping it on, and it's about finding something that works for everyone. So that is sort of the basics on how we do this. I'll hand over to Ryan now to take you through a quick overview.
Thank you, August. So let's first talk about the oldest one, or simplest one, is called About API. So what it is really about, it's about define some properties, well-known properties for a cluster. So probably if I assume most of you are Kubernetes practitioners, you know that there's actually no single ID for a cluster. There's just not there. If you want to identify a cluster, it doesn't exist in the Kubernetes world. So here is what the About API is going to do, because when you have multiple clusters, now you kind of have to identify each other, so you can distinguish each other. So we only probably have 2. The one properties we have defined is called a cluster name, basically. So you can see here, the name is cluster1. You can name it. It looks simple, but that actually is something that Kubernetes doesn't have. And we are actually in the process of, we are going to upload our deck, so that you click into the link, you will see we are actually having a cap discussing more properties. We put in another 5 different properties that we think that will be useful. So please let us know, get involved, vote on that, comment on that. So that's kind of tied up to our second API. It's called the ClusterProfile API. So the About API is really sitting inside the individual cluster to identify what this various properties of this cluster. But in most of our multi-cluster world, we need a single pane of glass for the system admin, the fleet admin, to actually see what are my clusters, what do they do. That's where this ClusterProfile API comes. This is basically allow you to, let me see if you can see clearly. Yeah, okay. Hopefully you can see, if you have as good eyesight as I have. That allows you to actually sit in your control plane and see each individual clusters, what properties they have. Again, this tied up to the About APIs, so we're going to add more properties, well-defined community-driven properties into the About, and then bring up to this ClusterProfile API. I just put in the same link there. The next one is, after you decided that seen all these clusters, and then you decide that you want to place some jobs, place some workloads into some clusters. How do you do that? Right? You don't want to always kubectl into each individual clusters and do a kube apply. So we have a API called Work API. Basically allows you to, from the control plane side, it's kind of, again, think of that as Kubernetes, right? On the control plane side, you can place resources onto clusters. Just like on the Kubernetes side, on the master node, you can place that into a kubelet. So it's exactly the same idea. And August is going to, and we are both going to demonstrate how that works in real life. And the last one is, when you place all your applications into individual clusters, Is that it? Not really, right? You still need them to either talk to each other or can be accessible from your users. So that's where this Multicluster Service API comes into being. This allows you to actually allow different services with the same name. There's a namespace sameness. There's going to be a SIG multi-cluster talk tomorrow. We'll get into more details there, but you need to have this namespace sameness, and then for every service, say every service A, they can actually talk to each other, or allow another service or external users to talk to your service, even if they are sitting in different clusters, right? That's what you need. You don't want them to individually specify, I want to talk to cluster A service and cluster B service, and cluster B goes away, then it doesn't work. So you want to give this idea of all these services are the same. That's where the sameness comes from. And now we'll hand back to August about demonstrate some real cool shit.
Right, so I'm going to talk to you a little bit about an implementation of some of these APIs and some enhancements to them. And that's through the Open Cluster Management Project, or OCM. You can visit us down in the booth, all that kind of stuff. What is Open Cluster Management? Very high level, obviously we could go much deeper, but it's a hub and spoke model deployment, right? So we follow the hub kubelet approach. They name them clusterlets, which I thought was cute. It's something that runs on the managed clusters, and it gives us a weak autonomy, so we get resiliency. So if there's a network severance or something like that, we are able to remain running without losing what's happening on your managed clusters. Our implementation of work we call manifest work. That's, as Ryan said, how we deliver resources to the managed clusters. Now, we have added some things to the offering there. Our version of placement, well, we call it placement, but that's our way to dynamically select clusters based on some resources. I'll show you it very briefly, and Ryan will dive into it a little bit more. The idea is that we can select clusters in a certain way. If we want more CPU or different characteristics, we can use placement to land on them. And then at OCM, we include something called add-ons, which are a modular and very easy way to plug things in. So if you have something in a project and you say, I want to bring that along, I want to make it part of OCM, I want to use it there, you can go through the add-on framework. Now, we're going to go through every piece of this one, so sit back. Should take us about 40 minutes. No, I'm just kidding. Ha ha ha. Basically, I wanted to demonstrate how we map some of the SIG APIs against what we call them, because sometimes that part can be a bit confusing. I was confused by that. So when you look at things like the About API, we have a cluster claim. When you look at the Multicluster Services API, we do things with Submariner, and we might make it so it's easier to manage all your services. These are just implementations of what's happening in the SIG. We don't necessarily expect them to become dominant or anything like that. It's just how we use them and allows you to do different things with them. So we have the work and the ClusterProfile APIs. So that's fine. It's something to look at. It'll be with the deck. So I want to now quickly run you through a recorded demo I have that I'll talk through of deploying some work and a placement. And let's see how we go. Okay. So what I have is one hub and two managed clusters. And as you can see, I have manifest work. I ask the hub about it. It knows. The managed cluster, of course, doesn't know anything about that. Yeah, is that big enough? Yeah, it doesn't matter. I can't change it. So we'll go ahead and do this against the hub. The CRD is there, and just to prove that it exists, I like to look at these things. There it is. So the CRD is there. We're ready to go. Okay. So we run agents and on the managed cluster, so we have a registration agent and a work agent who are able to then grab the information when they need it. Now here's what I'm going to deploy. This is a simple piece of work, so this is my manifest work, and I'm going to deploy it to a namespace called cluster1, which will match the cluster that I want to deploy to, as Ryan was talking about. It's a service account, it's a deployment of Nginx, it's a specific version. There's no magic here, it's just a very normal deployment. So I'm going to apply that against the hub, the piece of work against the hub, and then I want to go ahead and take a look at what's happening there. So I'll use Cluster ADM, which is an OCM tool. You don't have to, but I like it because I like how it can display things and how it can interact with the environment, and I play with OCM. So here is the pieces of work that have been deployed against Cluster 1, and so we'll dive a little bit more on what's actually happened. Right, there's no pods in the Cluster 1 namespace on the hub. It's obvious, but I just want to be clear that this isn't happening on the hub. This is being sent out to the managed cluster. So I'll switch to the managed cluster, and let's go ahead and look and find these things in Cluster 1. Okay, they're not there, right? So why are they not there? I said it had to be in that namespace. That's for managing the cluster. When you look closely, I was actually deploying to the default namespace. So I can put it anywhere I want. It just have to have the namespace sameness across the cluster naming. So if we look at the pods in running on the cluster 1, I can see my Nginx deployment. So we can see that the work has actually sent that out to the agent and it started that up. And then if I check on cluster 2, I should not see them. And they're not happening there. So it's done exactly what I asked. You know, no smoke and mirrors. So let's take a look at the work on the hub. There's the hub in the cluster 1 namespace, which matches the name of my managed cluster. And there's the piece of work that the manifest work deployed. So let's be sure this really exists. I like my proof of life. So here's the deployment running. That's my Nginx deployment. And then furthermore, I deployed a service account. And again, it's just to show that this got through. And I also deployed I can take a look at the work. And what's really cool is when you use this method to deploy, you get all this information from the work. So I can now do automation based on these things. I can learn about them. I can grab stuff back in the spec where I find out the status of something. I can alert on it. I can see when it changed, when it does things. So I'm getting all this for free by using the work API. It makes my deployments across a managed cluster much more resilient, easier to work with. Now, the agent monitors the work through a hash. So if I do lose connectivity or I make a change, but I'm not talking, it'll see a change in the hash. It'll know to grab the new work and update things for me. So we've thought of everything, right? So what we'll do is let's actually go ahead and look inside one of the pods, because what I want to do is then make a change to the work. I'm going to change the version of Nginx. And so you can see that actually get deployed across the cluster that we've used. So I used an old version of Nginx just because that was there and it was easy. So I'm going to use a newer version to see that it can actually go ahead and deploy those pods and make something new come out on it. So I've changed it to 127.4. And then I simply just have to redeploy the work. And once I've done that, it'll sort it out for me so that I can go ahead and look at the different clusters and I can see that the work has been deployed. It's restarting the containers. It's doing everything I asked, which is just update the version. And in no time, my work's been pushed out to wherever I want. So I've managed everything from the hub, right? I've gotten all that value out of these work APIs. Simplest version you could come up with, you could show, and I did. My 16-year-old, she found it boring. Okay, she's not into that. But we now can see that it will work. And so let me just prove to you that the pod is actually been changed. I mean, that's kind of obvious, but again, I like to really see it. That's probably my marketing background. So there you go. We now have the running container. So what I really want to do now is just quickly jump into an example, a very simple example of our placement. So I'm going to clean up the work that we have here because I only deployed to one cluster. And I'm going to show you how I can deploy it to multiple clusters through placement. Okay, this last bit here. So back on the hub. And what I'm going to do is, using cluster ADM, I'm going to take a look at the clusters. Now remember, I have 2 clusters, and what I do in those is I have cluster sets. OCM sets up a default, like a global one, but I have a default cluster set I've built. That is a way of grouping clusters together in some way that makes sense. It doesn't really matter what they are, but that's what we do. I can bind the namespace that I want to use to that cluster set, which will allow the work to take actions in that namespace. And then I just have to create a placement. So a placement just simply says, and I am going to pause this for a sec. A placement simply says, put this work on the clusters based on something. Mine is so simple, it just says put it anywhere. And I say find 2 clusters that meet these criteria. I only have 2, so it's going to find them both. Yeah, so that'll deploy it to, I would expect to see the work on both clusters based on what I'm doing. So I create the placement. And now all I have to do is create the work to use the placement, and the placement will take care of placing the work. So the names are, talk to the SIG about the names, but I love them because I don't forget. So the placement exists. It'll handle all decisions. It'll work fine. It's the same piece of work as you saw before, except I don't have to explicitly call it as a manifest work. It's just normal YAML. So the deployment is set to go, ready, service account, the whole thing. And then I use cluster ADM, because I like to create that piece of work. in the exact same way I did before, but I tell it what placement to use. So I expect the placement to read the rules. Ryan will go into it a bit more deeply, and I will then be able to place that work across my multiple clusters. So you've seen it do it. It's now created that my first work on both clusters. And then I can prove that by showing the work running on the hub. So again, I didn't have to actually explicitly call that kind. It simply built the work for me. And there it is. So I have work running on both those namespaces on the hub, meaning that both my clusters with those names will have the work running on it in the default namespace, as we talked about before. And there it is running on cluster 1. And there it is, in a second, running on cluster 2. And that demonstrates at the very simplest level of how we've implemented the work API and added placement to make that work. And now, I'm going to show you how to do the same thing with KubeFleet from Ryan.
Thank you very much. This is, thank you. Yeah. So we have this new project called KubeFleet that is recently contributed to CNCF. So a little bit about KubeFleet. It's, again, very similar. A lot of concepts are very similar with OCM. So we provide you a single pane of glass for the fleet admins to do multi-cluster application management, just exactly like of this demonstrated. You have one hub cluster, you do your thing, and then you don't have to go to your each individual cluster. Imagine you have like 20, 50 clusters. That will save a lot of your headache. And based on that, we provide a lot of scheduling capabilities. Basically, we copy-pasted a whole bunch of Kubernetes concepts, affinities, topology spread, preferred, required during scheduling, preferred during scheduling, all things like that. And we also introduced some different flavors of policies, placement policies, just as the demo is. You can pick how many clusters you have, or pick all of them, like a daemon set. And also we add a property-based scheduling. That is why we tied into this About API, ClusterProfile API, is when you have the properties, normally one of the main reasons we have properties on that is for the admin to see where you put it. So we have property-based scheduling. And recently we built this building a continuous deployment strategy, because we actually have a demo tomorrow if you are more interested, but today I'm not going to demonstrate that. And then the same thing, exactly like what OCM just showed, we implemented all these APIs as close as we can to the SIG-Multicluster standard. And let's jump into a demo. Anyone want to see a live demo or a recorded demo? Yeah, okay. That's the spirit. Let's see. Okay. So here I've set up a fleet. I don't know how, is it
big enough?
Big enough? I can make it even bigger.
Go bigger if you can, yeah.
Okay. That's the biggest I can get.
Okay.
Yeah, that's live, so you know that's all errors you made will be there. The problem with live, a big one is you probably cannot see the rest of it, so you can see that it has available CPUs. I don't know if I can. I don't know how to. Yeah, but you can see we have 1, 2, 3, 4, 9 clusters joined to this fleet, right? And there are properties at the right side. There's available CPU, available memory. I think I can do wide. Oops. Again, I cannot spell. So then you will also see available allocatable memories, things like that. Those are the properties. And cluster we create a cluster, I cannot spell, profile. So we create a cluster profile for each cluster. But the cluster profile currently doesn't have all these properties yet, so we cannot really do scheduling based on that. So we show the cluster profile. The next thing is the cluster properties, right, about API. So let me see. So the main placement equivalent API in the KubeFleet is called, let me see, where's my, this guy. So this, hopefully, again, if it's hard to see, but hopefully you can get some idea. We have this topology spread, affinities, but here is where the properties comes in. So we have a property sorter. So I showed you previously you have available CPUs. So we can say, in this one, we would say that, because sorting order descending, then we are basically trying to find the cluster with the most CPUs, with a weight 50 of them, and also a cost. Probably this should be ascending, but there's another property. So we can do all these. If all these with Azure are Azure-based properties, and with this, the Kubernetes ones are the public properties. And then we also have required during scheduling, all these things. We want to be, the memories has to be over 13 gig. But I just come up with a number because we have clusters that don't have that many memories. So this is how we use properties. When the ClusterProfile API, the link I sent there, when we have a common community-driven properties, we are going to adapt to that. So this is how we do the property. And now let's take a look at how it does. KubeFleet. So this is similar to what our placement is. So again, those are the, let's take a look at the status. So what it says found all cluster needed, found 3. So we asked for 3, give us 3. And let's see what it has. It has, so it's called bug bash 3, bug bash 4, right? So let's just take a look at this. How do we, so we grouped a whole bunch of stuff. Oh, sorry, maybe I didn't make it that clear. Here is resource selector. So what do we select? We selected a namespace called Multicluster App here. Right, so basically the idea is I have an application sitting in a namespace. I want to decide, the fleet admin want to decide where this application should run. Right? It pick all kinds of properties or criteria, say I want to run there. So now we actually want to place that application to the cluster. That's where the work API comes into being. I'll show you something very similar to what OCM does. So now let's take a look at the namespace, right? So the magic is we put it in the corresponding namespace there, and we have a work object there. Let's see there, yeah. So that object is there, and I think after the previous demo, you're pretty familiar with it now, hopefully. It's very similar to what maybe I didn't do the, so you can see it's the same thing, manifest, name. So what we place a namespace, we place the service, and we place the deployment, and then the last thing, we place the service export. So now goes to the last API we're going to talk about, service export. So before that, just like Oscar's want to do, I want to prove live, like we actually place it there, right? So let's see. I think it was 3. Let's see if it's there. Right, so it's there. Let's just take a quick peek what's inside. Yeah, so it has deployment, and just to do the same thing, let's see, we pick something that is not there. Let's say, I don't know, I don't think this one is there. Does it have anything? Nothing, right? You can find something. Just pick another random stuff. Doesn't exist, right? So we only place to where it should be. So now comes back to what the service export does. So with the service export, so we place it in, I think in 3, 4, and I don't remember what's the next one. Just let's say 3 and 4, right? Yeah. So at least 3 and 4 are there. So now you have an application at least sitting actually 3 clusters. I just don't remember 3 clusters. And then now you have a customer, right? Customer say that's your storefront, right? The customer's store app wanna buy something from your store. So how do they do that? They are not going to talk to the cluster specifically. They are going to have an endpoint. So that's where we put a DNS. Just basically, it's a load balancer in front of it. It's a DNS-based load balancer. And that one is called, let me see if I still have the command, it's long. Don't want to, this one, no? This one, yeah. So we have a traffic manager there, and this is the DNS name. And okay, let me just, so it has a DNS name, endpoint. And then, I forget the name. So I will show you how we use the service export, right? So this is called endpoints, all right? So it's anyone familiar with gateway APIs? It's similar as gateway API. You have a gateway API, and then you have endpoints. So this is our endpoints, and then the way you use that is pointing to your service import. Remember, when you have service export on your clusters, we automatically create a service import somewhere else so that you can access that. So we have that service import, and I show you where the service import is. I think it's in the same cluster. Yeah. So we have this service import. Yeah. So it says how many clusters? It has 3 clusters, 3, 4, and another one. Basically my name there. It has ports. So that's how you get this storefront. And if you look at this one, right? So it has a DNS name. Oh no. This one, right? It has a DNS name. Yeah. And now you want to dig that. See if you can. Yeah. Now you see this actually in here. Let me see if I can get another one. Didn't change for.
Curl it a few times.
And we can curl actually.
Force it to use it. Yeah.
Where did it go?
Dig it.
Dig it again. Same, but that's the part of life. But just believe me, it's actually going to 3 different places. That's about the demo. Hopefully, if you have any questions, you can grab me again. The setting is still there. You can play with it if you like. So finally, there's one shout out is our project is so new, we don't even have a logo. So if you are interested, if you feel like your taste is good, please vote for the logo. May the best logo win. Okay, that's it. Thank you very much. We have a Q&A.
Yeah. Nailed it. That's good timing.
Any questions? Yeah. Is there a mic somewhere?
I mean, I could just come up if it's easier.
Where is the question from?
He's there.
Thank you.
He's going to the mic, yeah.
Hi. So great talk. Thank you. I do have a question. It seems to be right now oriented at spreading your blast radius if cluster goes down geographically. But say you have just 2 clusters side by side and you want to guard yourself against doing an oopsie and taking a cluster down. It means that if you are a developer and you want to present your developers with a unified view, say a nice Argo CD dashboard or something like that, it is still going to be represented differently because those tools, as far as I know, just like Istio or Kiali, they aren't really that multi-cluster aware and definitely not aware in the federated sense of awareness. Is there any integration with other SIGs, with other projects where they're working on this, or is that something that's a little bit more further out into the future?
You take it.
Yeah, definitely. So this is just a tiny portion of all our projects. We have a lot more features there. I believe OCM also have a lot of features like that. So actually, I will have a demo about how does this KubeFleet work with Argo CD, exactly how we work with. That's the beauty of common API. When you have a common API, the other projects can integrate with an API instead of integrating with a specific project.
And that's very much what I was trying to call out is if we can keep to this, then those empty boxes you saw on that slide, they are anything in theory, so that we can make sure we don't go down that road. And that will be the way to do it.
Yeah, because it's a spec, not an implementation. Yeah.
Yeah.
Yeah, that makes sense. Yeah, and because it is essentially a single control plane, anything that could talk to an individual API server would technically just be escapable to talk to a hub API server, essentially, because it's just CRDs.
Yeah, I mean, is there a minimum number of clusters? I mean, in some way, it should be one, because you always want to grow. So if I'm always managing in a very standardized way, then I'm in a good space.
Yeah. I actually have a secondary question, which is probably going to annoy everyone, although there's no line. Great. So say you have a work, and that's deployed, and your spoke clusters are executing this work happily. If you now go and manually modify that, will a controller or a reconciliation loop reset that back to the desired state?
Good question, and I feel like you have been there. So yeah, so at least for KubeFleet, we have it's called drift detection. We have takeover, drift detection, diff reporting, all these goodies in the work API, but we haven't upstreamed that yet. That's actual work. We need to get everybody agreed on the API, and we can upstream all these good features there.
All right, cool. The takeover part sounds interesting.
Yeah.
Yeah, I guess we'll talk about it later.
A lot of times, before they can adopt OCM or KubeFleet, they were doing this old way, right? KubeCado into everybody. And then when you take it over, you want to make sure that you're not accidentally override something that is specific for that cluster. Incident will happen. So that's definitely something I know the real admins are worried about. Yeah. That's why we have those features.
All right, cool. Third tiny question, how does the authentication in the demo, is it just service accounts from the hub talking to the spoke, or is there?
Other way around. We both have this pool model, so it's the member agent actually is authenticated onto the hub cluster. So the hub using different ways, you can do all kinds of ways. If you're a cloud provider, you can use OIDC and get this federated identity, things like that. Or you can use old-fashioned secrets.
Yeah, similar as the cluster secrets in Argo, essentially.
Yeah.
Right, cool. Thank you very much.
You're welcome.
Hey, thank you for your talk. I have probably a very small question. I noticed that the work API specs don't specify any resources. So can you tell us more a bit about like the scheduling and placement of workload? How do you handle placement decision? Do you kind of look into the manifest and every time evaluate the resources required to place the workload? What do we do there?
I'll leave it with you, the engineer.
So,
you know better than me.
So the idea is work is really, there's no intelligence built into the work API. The work API is a workhorse. It does whatever it is told. The intelligence is in the placements, like we both demonstrated, that the placements say, that's where we pick where to put the stuff. When we decided where to put, we just envelope them into a work API, and that work object will get blindly copied into the cluster that it needs to be. So the intelligence is mostly on the placement side.
All right, thank you so much.
You're welcome.
Hello.
Hello.
Thank you for the talk. So is work intended to be a whole collection of resources that's deployed to a cluster, or can you have a single piece of work that is split across clusters as well?
Yeah, because we all know there's a 1.5 megabyte limit, right? So if you want to place a lot of stuff, you have to break it. And for the work API, is just designed to hold individual ones. If you can put them, say you have 10 pieces, you can put them into one if they can hold, or you can put it into 10 different work. Either way works. Although I probably don't want to put it too fine-grained.
Yeah. As a human, you have to manage it, right? You make it overcomplicated or too disastrous if it goes wrong. You want to make sure you have that flexibility.
Thank you very much.
You're welcome.
Hello, thank you for the talk. My question relates to what you said about placements. It looked like placement specification is statically defined. So you're saying, hey, this cluster has got this much CPU or this much memory. If you're in a scenario where you're using something like Carpenter, which is going to dynamically scale up based on the workload that you're trying to put in it, how are you going to choose the right cluster to go to?
So one thing to correct, it's not static. So I can demo again. If you run some workload into one cluster, you will see the available CPUs changed or reduced. So it's not static. There is actually a lot of discussion in the SIG about whether we want to keep those properties into ClusterProfile API, because to us, those are very dynamic properties. And initially we decided that for the about API, we do not want to put in any, like Stefan is there, you can add more. We do not want to put two dynamic properties into that. So there could be, from the SIG level, we don't have a solution for that. From the KubeFleet side, we basically collect our agent sitting in the member cluster or workload cluster, collecting all the metrics, and we update that with a certain cadence. So that, and I know OCM-io and other projects have their own way to solve that, but on the SIG level, we don't have a solution yet. So if welcome to our SIG meetings and propose any solutions to us, that'd be great. And again, we will have a talk tomorrow afternoon about the SIG APIs, so that could be another good question there. Thank you very much.
I might just go in one more question, as there wasn't a queue. Where are you at with integration with Gateway API at the moment? Because obviously you demonstrated there something that wasn't really aligned with how Gateway API works. So where are the two SIGs talking a lot?
I would say we talk. I'm not sure if we talk a lot. Last time we talked, the basic idea is exactly what I demonstrated, but there are nitty-gritty details like how do you actually shift traffics between two same services. There are some, again, nitty-gritty details we still need to iron out, but the idea is the same. And we should talk to network more, or yeah, definitely. Thank you for this reminder, yeah.
Thank you.
Hi there. Thanks for the talk. Can we use the placement to make sure that different works are distributed across a fleet of clusters so that there is the distribution of the different works are more balanced? Because a lot of times we have multiple clusters, but each of those clusters are different in size. Can we actually use this to maintain balance the size of the clusters across different clusters?
The answer is definitely yes. Again, this is not part of the SIG API. In our individual projects, we definitely have those ways. Depends on how you want to rebalance, right? There are two ways to balance. One is static balance. So when you do the placement, you find out all the clusters. But clusters get out of balance after a while. So that you can also do dynamic balance. But all these are not built into our current SIG ones. KubeFleet can handle that, or we have different ways to handle that, and we have plans. If you want to know more, we can talk individually down there. But at a SIG level, we don't have you notice that we actually don't have a placement API yet. We probably like to work towards that if possible, but placement is a very complicated scenario. Just imagine how many knobs you can turn in Kubernetes when you place a pod. Right, so we are pretty far from getting to that standard yet. But I think hopefully that's the goal for this SIG multi-cluster. Again, we need more involvement because we do not want to basically decide it for the community, right? This is pretty much the community standard.
And placement across different environments, right? It's going to really depend where you are and what's best. And so some of it needs to be left really for the implementation. Depending on where you want it. So at the product levels, I know we're dealing with it in certain ways because our type of product needs to be on Metal or somewhere else. So I'm curious to see where that goes as far as placement. It's like the fifth API there that isn't there.
The fifth API, I kind of supposed to rule them all, but it takes some time to get there.
Yeah.
But I had another question. I see that OCM has the support for IRSA for AWS now. I saw that in the latest release.
Yep. To run the hub on EKS?
On EKS,
yeah.
Yes. Is that, was that like is KubeFleet and OCM kind of differ in that, like how these things are implemented when it comes to authentication? And is there a standard around that? Why was it missing in OCM before?
Why was it missing in OCM? Boy, well, we needed someone to do the work. We needed the AWS expertise to work with IAM, that kind of stuff. There needs to be the resources to do the work and a reason to run it there. And that gets driven from different levels, upstream, downstream, that kind of thing. That's a tricky question to kind of answer openly like that. So yeah, nothing blocked it, just resources, and the team that worked on it just wanted to tackle it and was able and had that knowledge of AWS to do it. We're thrilled to see it running on there because obviously it runs nicely on OpenShift, but the more environments we can see it on, the easier it is for customers to manage in those different environments. I don't know if you have anything to add, but
Unfortunately, I cannot speak for OCM.
no, but I mean on your side, so
KubeFleet as an open source project works on any Kubernetes. So, and it works on EKS, GKE, AKS, whatever. Yeah, so there's no it's basically vendor neutral. It does have a provider model, just like Carpenter. So welcome, I don't know if any EKS, GKE folks are here. Welcome you to implement a provider there so that it can seamlessly work on everything, have all the features. If you don't have a provider, some of the features like the property, like the cost property is the provider that is only Azure member agents can provide that. But if you run it on EKS, GKE, you won't be able to get that.
Thank you.
Welcome.